Okay, guys, welcome back to day 7 of the Advent of Code. So what we've got today is we've got this rope bridge. And we've got these equations here. But someone has stolen all of the numbers. All of the operators. So all of like the signs in the equations. So what this would actually be is it would be 190 equals 10, and then we can either use adding or multiplication to get it to equal to 190, and in this example we can see it's multiplication. And what they want us to do is they want to see how many of these equations can we make true by inserting a plus or a multiplication somewhere in here. They tell us that they're always evaluated left to right, so there's no BIDMAS rules that are going to apply here, and they want us to add up all the sums of all true equations. So, once you understand what the problem is asking, is not too bad to implement in code. So let's take a look at the implementation. So I load the file. Then I think this is pretty inefficient, but it is what it is. So what I'm doing here is I have to use 64-bit integers for this because in our input data set, if we take a look at our input data set, what you'll see is that we've got some pretty big numbers, and some of these numbers are too big to fit into a 32-bit integer. So definitely that. So that means that we have to use 64-bit integers. Now, I decided to use 64-bit integers for the numbers in the equations as well, like the numbers that we're going to be adding or multiplying, just to save on typecasting. So I get that data to lines, and then I map through it to convert it into the type that I want. So first of all, I split it. So where the equal sign would be with the colon character that they used. The target value is just the value before the colon, so the first part. So we're using an iterator here, and we pass that into an I64. Then our numbers are represented as a vector of 64-bit integers, so we just iterate through. I'm wrapping because we know that they're all going to fit into 64-bit integers. We split them by white space because that's what they did in the training and just the data set that they gave us. Then we map through each number and we pass them into 64-bit integers. Then we collect them into a vector. Then we return this tuple of a 64-bit integer and a vector of 64-bit integers. And then we collect that into a vector of tuples. So that's our data set. Not too bad to work with. So in this case, parts 1 and parts 2 are pretty closely linked. They both depend on this function down here. But first, let's take a look at part 1 exclusively. So part 1's a 64-bit integer because it's the sum. We iterate through our data, and then we filter our data, and we say is target solvable with these numbers, and ignore that. That's for part 2. And then we map through them, say that we only want the targets because they only wanted the sum of the targets. So now we have a list essentially of all of the targets of the valid equations, and then we sum them, and that's part 1. So let's take a look at the isSolvable function. So what we do is we take in the target and we take in the numbers and ignore that. That's for part 2. We just initialize our results variable here with the first number. Then we iterate through the rest of the numbers. We say that we get an iterator of results and we flat map it. So for part 1, we're looking at this part because we're not concatenating. So we do the result times the number and the result plus the number, and then we flat map that so that we can get one vector at the end. So what this gives us is all the possible results. So all the possible results that we could get based on whether we're using multiplication or addition. And then what we do is we simply just check, like, would it have been possible to get the target by checking, is the target in our list? And if it is, then it must be solvable, so we're returning true, and else we're returning false. Cool. So nothing too complicated there. I think we will now go and take a look at part 2. Let me just get back to Chrome. Cool. So here we are down in part 2. Calibration result. Oh yeah, they forgot to tell you about the third type of operator. So this is concatenation. So 1 to 12 and 345 becomes 12,345. Literally just concatenating them. Now, yeah, and look, you can make sum true for concatenation. You can concatenate, add, and multiply, any combination that you like. So this, I think in other languages would be really simple, and in Rust is pretty simple as well. There are ways to concatenate. So we're using the same is solvable function, but we're saying that we're using the concatenation operator this time. So the most popular way that I know, at least, in Rust to concatenate is to use the format macro. So what the format macro does is we'd say format exclamation mark, and then we'd give in a string like this, and we'd say like A, B, and that would concatenate those two as a string. The problem is now we've got a string. Now we've started working with strings. So now we need to pass that. We'd have to pass that back to a 64-bit integer. And we'd have to like unwrap, blah blah blah, all that stuff. And because we start working with strings, that would really reduce the efficiency of our algorithm. And I was originally doing that, and then I was like, okay, why is this so slow? Okay, here we're working with strings. We don't need to be. And then I had a little bit of a look around online to see if there were any better ways to do this. And I found that there was. So let me explain to you what we're doing here. So we take our result, and we multiply it. So we want our result and our number to be concatenated, right? So we take our result and we multiply it by 10, and that just means 10 as a 64-bit integer. We multiply it by 10 to the power of, and this checked I log 10 here basically gives us the number of digits. Then we have to add 1 to get it to the correct number of digits. So this handles edge cases. We just assume 0. So now we know the number of digits, right? And we're raising that by the number of digits in n, right? And we're raising r by 10 to the power of that, right? So let's use 12 and 345 and as an example, right? So in n, which is 345, there are 3 digits. So if we multiply r by 10 to the 3, we'd get 12,000, right? And now we've just got zeros. So to concatenate them, we just add on n to that result to get 12,345. So this is a really efficient way because we don't need to do any type conversions. And I'd say like one of my biggest learnings from the advent of code so far is just wherever possible, just try and work in the same type. Whether that's different types of integers in Rust, and especially like, you know, don't convert your integers to a string. It's gonna use up more memory, and it's just unnecessary. So yeah, that was day 7 of the advent of code. I didn't find it too bad. Hopefully you did well too. Thank you very much, and I'll see you next time for day 8.